Hi, my name is Mr. Chu and you're welcome to my study room. Today we are multiplying binomials using Algebra Tiles. We are going to use virtual manipulatives from a website called polypad.org. Let's get onto the computer quickly and do that. In your browser, type polypad.org. And enter. And that brings us straight or directly onto the Mathegon website. I already have a video which explains what algebra tiles are and how to use it, but for the sake of today's lesson, let me use a few minutes to explain the key things we need for this particular study. But then I will quickly encourage you to watch my video on what you need to know about algebra tiles, and you have a lot of understanding from there. I'm sharing the link here and it will also be in the description box as well. Right, so let's get into the few things we need to know to help us do today's lesson. The first tile we need to know about is the unit tiles. The unit tile is a square tile which has the value 1. Then after that we go to the X tile, which is a small rectangular tile that has the value x. Its length is x unit and the width is 1 unit. And let me say a few more things about the X tile. There is no number of 1 unit tiles that can fit exactly onto the length of the X tile. Let me just show that for you to see what I'm talking about. So we have 5 unit tiles that don't fit exactly. Immediately I add a 6th one, you see that it will be longer than the X unit. So there's no number of unit tiles that can fit exactly onto the length of the X tile. But you remember I said the dimensions are x by 1. So when you check the width that I said is 1 unit, you see that the 1 unit fit exactly onto it. So that is why it's x by 1 unit. So the 1 unit tile can fit onto the width of the X tile, but no number of unit tiles can fit exactly onto the length of the X tile. Then after talking about the unit and the X tile, we come back to the X squared tile, and this one too, each side is x unit long, so the length is x unit and the width is also x unit. Right, so the length and the width are the same, and this makes it a square of area x squared. Each tile also has 2 different colors. For real algebra tiles that are sold in bookshops, we have the main color at the front, and when you flip it or the back, you have a red color there. So for example, with the unit tile, if the unit color is yellow or orange, as in this case, the back will be red. Then the X tile, which in this case is green, the back is red. And then the X square tile, which is blue, the back is red. And in each case, the main color has a positive value. So with the unit tile here, the orange is positive 1, and then when we flip the back to get the red, we have negative 1. And also for the X tile, the green color is positive x, and when we flip the back, we're going to have negative x. Then we come to the X squared tile. The main color, which is blue, is x squared, and when we flip the back, we're going to get negative x squared. So that is it. This is virtual, so we're having 2 tiles to represent each of them. But with the actual algebra tiles, when you flip the back or you turn it, the front will be the green or the positive, and the back will be red, which is the negative. So the main color for positive values and the red color for negative values. In that video I just spoke about, we use the tile to demonstrate or model different algebra representations. For example, to model an expression like 2x plus 3, we will be bringing 2x tiles and then 3 unit tiles. Right, so for more of these, I would strongly encourage you to watch that video so that we go on to the main lesson for today. Let's start with multiplying a binomial with a monomial. A binomial is simply an expression that has two terms. So for example, this expression we have here, 2x plus 3, is a binomial because it has two terms that are separated by an addition sign. We'll start with a very simple expression like 3 multiplying 2x plus 3. Here we are just going to use the distributive property just like the way we do with algebra. So this 3 here will multiply 2x, and then the same 3 will multiply 3, and then that is going to give us the answer. But now using algebra tiles, we will first draw a T-chart. We put our multiplication sign here and model the multiplications with our tiles. Then after drawing our T-chart and modeling our factors, so we have 3 here, 1 2 3 tiles here, then we have our 2x plus 3 also here. Then now our aim will be to form either rectangles or squares here depending on the factors. So first of all, each tile here is going to multiply each tile here, and then we put the result in and we count the final thing here. So let's do that quickly. X times 1 is going to give us x, so let me put that here. Then x times 1 will give, each of them will just give us x, so let me do that quickly. Then each one unit here multiplying the 1 here will give us 1, so let's put that quickly. Right, so after modeling the multiplication, we now remove the outer tiles and count the inner ones. So this is going to give us 1 2 3 4 5 6x plus 9. So that is, this multiplication gives us 6x plus 9. Let's model another one. Say x multiplying 3x plus 4. So again, we model that in our T-chart quickly. Right, so this is a representation of our expression, this x and this 3x plus 4 here. So we're just going to do the multiplication again. X times x is going to give us x squared. Then this x times x is giving us x squared again. Then this x times x again gives us x squared. Then 1 times x will give us x, and each of them will still give us x anyway. And then let's not forget to remove the outer tiles. Then after that we count the inner tiles, and that is going to give us x squared plus x squared plus x squared. So this gives us 3x squared. Then 1 2 3 4 4x, so plus 4x. So I hope we are getting where we are arriving. Let's take another one. Like just changing the addition here. So let's say x multiplying 3x minus 4. And we model that quickly. So just like this one, the only difference is the -4, which is right here. So we do the multiplication. Right, so this is the model, and each of the x's here multiplying the x here gives us x squared. And then look at here, each of the -1 multiplying the x here gives us -x. So all we need to do is to negate this for x to give us -x. And then let's not forget to remove the outer tiles. And from what we have here, the answer is going to be 3x squared minus 4x. Now let's go ahead and multiply two binomials. Say x plus 2 and x plus 3. Just like we did with a monomial multiplying a binomial, is the same thing that we'll be doing with the product of two binomials. We are going to use the distributive property, which involves the FOIL method. FOIL. And I hope most of you know this already. Meaning we multiply the first terms, outer terms, inner terms, and the last terms. So that means that this first term here will multiply the first term here. That is what the F stands for, the first terms. Then outer terms, meaning this one will multiply this one here. Both of them are outside. Then we come to the inner terms. Both of them are in. Then the last terms. First last term multiplying second last term. So that is just what we're doing. But then we have to model that with our tiles. So let me do that quickly before I explain. Yeah, so here we have our x plus 2 and our x plus 3 here. So we do the multiplication just like we're doing. So x times x gives us x squared. 1 times x gives us x. Each of them gives us x. And this x multiplying each of the ones here will also give us x. Then each of the ones here multiplying the 1 will still be 1. After modeling, let's not forget to remove the outer tiles. After that, let's put all together. We are going to have x squared plus 5x then plus 6. Let's try with just the conjugate of each of these. Conjugate means we are just going to change the sign for each of them. So let's have that quickly. Yeah, so I just modeled this by leaving it just like the way it was when these were addition. I've done that intentionally so that we can go through the process together. Remember, this is x minus 2, so the 2 must be negated. Just have to select them. You click on negate and it becomes minus 2, and then the same thing here. So x minus 3. Right, so x times x gives us x squared. Each of the -1 multiplying the x will give us -x. So we need to change this one to -x. So we just have to select them, we negate them. Each of them give us -x. And also x multiplying each of the -1 will also give us -x. So let's do that quickly. Right. And then for here, negative multiplying negative will still give us positive. So -1 times -1 give us +1. So we leave that way. And then let's not forget to remove the outer tiles. and then count what is left. So we're going to have x squared minus 5x plus 6. Why not try the following on your own and share the answers with me in the comment section? Here I just gave you two products and then they are conjugates. So take your time and work it well and share the answers with me. Let's have it a little more complex and see. For example, 2x minus 4 multiplying x plus 3. Let's model that quickly. Right. So here we have 2x minus 4 and then x plus 3. X times x gives us x squared. X times x gives us another x squared. Then negative 1 times x will give us negative x. Each of them will give us negative x. Then 1 times x, each will give us x. X times 1, each will give us x again. Then negative 1 times 1, each will give us negative 1. After modeling, let's not forget to remove the outer tiles. And then now we put all the tiles together. We have 2x squared. But here we have both positive and negative tiles. And you remember 0 pair? Right. So each negative x tile here will cancel out a positive x tile. So let's do that and see. The 4 will cancel out 4 of the 6 positive x, and that will be 0. So we'll be left with 2x squared tiles minus 12. Let's try another one. We have 3x plus 3 multiplying 4x minus 2. We go ahead and model that quickly. There we have it. 3x plus 3, then 4x minus 2. Let's model the multiplication quickly. Alright, so here we have it. The bigger the numbers, the larger our diagram is going to be. So each of these gives us x squared. Then the negative 1 multiplying each of the x gives us negative x. Then the positive 1 multiplying each of the x gives us positive x. And also positive 1 multiplying negative 1 gives us negative 1. Let's not forget to remove the outer tiles. We will now put the rest together, not forgetting to put together different colors of the same tiles. So let me do that before I go on with the counting. So this gives us 12x squared. Then we are left with 6x. So plus 6x minus 6. Let's try conjugate and see. The first one is x plus 3, then x minus 3. Let's model that quickly. Right, so modeling this one, we're going to get x squared minus 3x for each of these multiplying the x, and then plus 3x for each of the ones multiplying the x, and then minus 9. So as usual, we have to remove the initial tiles, and then we combine like tiles. These three cancel out, and that's going to give us x squared minus 9. Let's take another example. So we have another conjugate multiplying here. They are conjugate because the only difference between them is the sign. One of them is subtraction and the other is addition. Let's see what this also gives us. We model it quickly. This shows the model of the representation of this. So we have our 2x minus 3 here, and then 2x plus 3 here, and then this is the model. As usual, we take away the initial tiles, and then we now put this together, but we shouldn't forget to combine like tiles. So this gives us 4x squared minus 9. Then let's do perfect square. So let's first try x plus 3 all squared. And I hope we know that that means x plus 3 multiplying x plus 3. So perfect square is just a number multiplying itself. We model that quickly. So we have our model, and then as usual, we take out the outer tiles, and then we have x squared plus 6x plus 9. And this is our answer. I would like you to pause the video and try x plus 5 squared. I'm sure you should have x squared plus 10x plus 25 if you do it well. Right. And this is where we bring today's lesson to an end. I hope this lesson has been of help to you. If yes, then kindly consider subscribing to this channel for more videos. Till we meet again, it's a bye.